Hi class, welcome to this new video of tutorial 4 where together we will solve question 8. Now, you are given a matrix A and the first question you ask here is to find the determinant of A. So, you can use many methods to find the determinant of A. You can use the row expansion or the column expansion. Um, but here and we have ever advised you that it's always easy to use the Gauss reduction method whenever it's needed, right? So here what we see is that since we already have the pivot here one, so we have zero here, so we can make a zero here, right? By making R3 equals to R3 plus 2 R1, right? So this will give me 1 minus 3 minus 2, 0 to 1, 0, 0 minus 5, right? 0 minus 5 minus 1. Okay, from here, I can directly find, complete my determinant since I already have two zeros here. I have 0 here and 0 here. So you use this as my pivot, then I can then find my determinant, right? Doing this. So I will do that determinant of A is equals to 1, 3, minus 2, 0, 0, 2, minus 5, 1, minus 1, right? Which is equals to 1 times 2, minus 5, 1, minus 1, which is minus 2 plus 5, which is 3, right? So determinant of A is 3. Good. So the next question at B is that does matrix A have an inverse, right? We can give a quick answer. A quick answer is yes. Why? Because determinant of A is not 0, right? So, and then in question C, you are asked to find the determinant of A squared, right? And we saw that before using the property of determinant of A squared is equal to determinant of A all squared, right? Which is 3 squared, which is 9. Question D, you are asked to find determinant of A power n, right? Using the same properties, right? We have that it is 3 power n. And at E, you are asked if it does exist. Does there exist a positive integral that which an has an inverse? So they're asking you if there is any n for which matrix an has an inverse, right? Sorry, it has no inverse. It has no inverse. So the answer is no, right? The answer is no, because the question is, does there exist a positive integral n for which an has no inverse? So the answer is no. An has no inverse if and only if determinant of an is equals um to 0. If an has an inverse, if and only if this was to 0. So the question is, can you find a value of n so that 3 power n is 0? No, it's not possible, right? And at question F, we have that b equals to a squared. The question is that how many solutions does bx equals to 0 have? Now, how many solution does bx equals to 0 have? So we know that, look carefully, we know that b equals to a, square, right? Therefore, determinant of B is determinant of A square, which is 9. So we see that determinant of B is different from 0. Therefore, Bx equals to 0 will have a unique solution, right? Only one solution. Now, let's look at G. It says that consider B equals to A square. How many solutions with Bx equals to B have if B is not 0? How many solutions? So we will use the same we will use the same logic, right? That we have a that B equal to A square. So determinant of B is equal to determinant of A square, which is 9. So determinant of B is not 0. Therefore, only we will have only one solution, only one solution. So therefore we will have one solution, right? Now at 8, you are given that C equals to 1, 0, minus 2, minus 3, 2, 1, minus 2, 1, 3, right? And you are asked the question, if is C dependent or independent? So have a close look at the set of vector C. You will realize that this vector 1, V1, V2, V3 are representing the column of matrix A. Because remember that matrix A was defined as follows: 1, 0, minus 2, minus 3, 2, 1, minus 2, 1, 3, right? So you see that V1 is this column, V2 is this column, V3 is this column. And we saw that determinant of A was 3, which is non-zero, right? It means that the set, we can then conclude that the set of vector C is what? Is independent. Why? Because determinant is non-zero. Okay. So if we look at I, we have still another set C, but this time is 1, minus 3, minus 2, right? 0, 2, 1, and minus 2, 1, 3. The question is C dependent or independent? Now, since we have this question, we also need to have a close look on this. Now, if you look at this vector v1, v2, v3, you will see that this vector, they represent the column of the transpose of this matrix. Now, if this is A, therefore transpose of A is 1, minus 3, minus 2, 0, 2, 1, minus 2, 1, 3. You see that the vector of the set C represent a column of transpose of matrix A. And we saw that determinant of A is also equal to determinant of transpose, then is 3. Therefore, determinant is non-zero. So we can still conclude that the set of vector in C is independent. Okay. So I advise you to use the same procedure, the same logic to be able to solve question 9. Thank you for your kind attention.